Okay, I'm observing the planet Jupiter. Tonight is the second night after the storm, and the air is turbulent. I'm using the SkyWatcher DS Pro 120 Apochromatic telescope. I'm using a range of eyepieces. This is the 8mm Ethos. This is the 8mm SkyWatcher SWA. This is the 3.5mm SkyWatcher SWA. As a finder, I'm using Maxvision 28mm, and this is the Myriad SkyWatcher Myriad 3.5mm. It's very good. Air is turbulent, but it shows a lot of detail, better than all of them. Shows a lot of detail. I must say that this SkyWatcher is better than the, in a way, better than my Lyra. The light scatter of it, this eyepiece on this telescope is less. Lyra is a very good one. It's a Fraunhofer Apochromatic telescope. It's Doublet. This is a Doublet Apochromatic with a fluorite glass. F7.5. That is F11 Lyra, and the image quality is both the same. I think the chromatic aberration in both of them are well controlled. A little bit in the highest magnification, which is 3.5mm provided, is slightly visible, but not much. It's not annoying at all. You cannot really complain about that. But the light scatter with this is better controlled. I don't know what's the reason, but definitely it's a good telescope in that sense. So I'm observing the eclipse of the Io on the disk of Jupiter. Very beautiful. Although this air is very turbulent, you see the waves of air moving over the disk of the Jupiter, but yet you can see the dot, the visible beautiful dot of the shadow of the Io on the planet Jupiter, on the cloud tops of the Jupiter. So, enjoying this. I'm continuing to go. This is 110 degrees. It takes a long time for the planet to pass the field of view. The turbulence in the atmosphere has really reduced now, and I can see clearly the dot, beautiful dot of the shadow of Io on the disk of Jupiter, on the cloud tops of Jupiter. I never thought that it can be that big. I can say the size of the shadow is actually the size of the Earth if it was on the Jupiter. It's comparable to that, although the Io itself is 1/4 of the Earth, is the size of the Moon. But this is beautiful. It's so delicate. The size of the Io on the cloud tops of Jupiter has changed. When it was closer to the edge of the disk of Jupiter, it was bigger, and now it is almost 2/3 to the middle, and it is smaller. All the turbulence is less, is smaller, less visible, more difficult to see. And I think that shows the size of the Jupiter itself, how big it is. On the edge, it was around, let me tell, around, 60,000, 65,000 kilometers further back, and that makes the size of the shadow of the Io bigger. And when it comes 65,000 or 50,000 kilometers closer on the near the bulge of the planet, that shadow cast is a little bit smaller. It's interesting. I can visually see that and confirm it. Okay, I'm now looking with the same setup to the planet Saturn. Just a few, I mean, 20, half an hour ago, it was full of turbulence, the atmosphere. It's now so clear. Can see Cassini gap, crepe, ring. I can see it. It's so clear. Amazing. This is 100 degree on 10 degree eyepiece, 3.5 millimeter. Myriad is beautiful. It's really great on that Saturn. Never saw Saturn so beautiful, so clear. Turbulence have disappeared. Just you see some very gentle waves sometimes through the atmosphere. That's a few, probably a few in every 10 seconds, but that's it. I can actually see some details on the disk of the planet, which sometimes I've seen this before, but I've seen for the first time the shadow of the planet on the ring. It's on the back of the ring. That's amazing. It's like that, as if I'm looking through one of the posters of Voyager of the planet Saturn from far a little bit. So you just see the yellow-orange colors mostly. It's like that. This is amazing. And it shows the aperture. This 120 millimeter aperture shows what it can deliver compared to the Lyra 102. That's amazing. That's beautiful. This is a superb telescope. I may be wrong, but I'm going to say maybe it's wrong. Maybe I'm aware of it. I think I'm seeing it. But I think I'm seeing the hexagon on the polar regions of the Saturn. I think I can see this. Famous hexagon. What I am going to say is more visible with the moon, but now I see it on Saturn. When you focus the focuser of the telescope, in this case this 10:1 dual focuser, triford focuser, the edge of the moon comes at a different focus to the center of the disk of the moon, center of the globe of the moon, sphere. Because there is a distance, you know, the 1,500 kilometer is the radius of the moon, 1,600, something like that. And so different focuses. This is very visible on the moon when you look at the fine details. I see the same here with the Saturn. You bring the Cassini gap into focus, the details on the disk of the planet fade away. You bring the disk to the focus, the details on the clouds, that is not a disk, it's a sphere of the cloud in the center where it is closest to you, supposedly. Then the Cassini gap, which is on the background, goes out of focus slightly. So you can actually see the distance by just simple focusing. You can actually find a focus distance for different parts of the planet. Saturn, imagine, is around 1 billion kilometers away, and I can focus on the center of the globe of the front hemisphere of the Saturn, and I can change the focus slightly and focus on the Cassini gap at the edge, near the edge. It's amazing. That's where this is more visible, of course. It's beautiful. The precision of these instruments, it shows human ingenuity have really gone so far. And, well, okay, we can say that I'm clever enough to notice this. In my line of sight, the distance between the center of the globe of the sphere of the Saturn to the center of the Saturn and parallel to that, perpendicular to that, the edge of the disk rings of the Saturn is around 45 to 50 1,000 kilometers. So I can actually focus in this distance. That's what I want to say. I can focus to 50,000 kilometers back or forward.